Hey guys, I'm Lucas, welcome to K-News episode 28, covering the upcoming Falcon 9 launch. Before I go on, congratulations to SpaceX for successfully landing their first stage back on the launch site on the previous flight. It was a really intense moment for me, and I hope many of you had the chance to see it live as well. In case you have missed it, don't worry too much because there are plenty landings ahead. The Falcon 9 is a two-staged rocket from the private company SpaceX, and it is equipped with 10 Merlin engines. 9 of them are used for the first stage, from which at least 3 can be reignited. The last Merlin engine is used on the upper stage and features a much bigger engine bell, which makes it more efficient in vacuum. The lower outside pressure means the exhaust expands more rapidly, and using a larger bell forces more of the exhaust gases to be focused in the back. This increases the thrust by 13% compared to a regular Merlin engine in vacuum. This will be the last Falcon 9 to be launched. In this specific configuration, of course. SpaceX upgraded the rocket, which they now call Falcon 9 Full Thrust. As the name suggests, it will have more thrust and more range when it comes to payload diversity. This means they will finally be able to launch big and heavy communication satellites to a geostationary transfer orbit, thus directly competing with the Ariane 5 for example, and hopefully still be able to return the booster stage. Their current client is NASA, and the payload behind its fairing is the Jason 3 satellite. The launch is scheduled for Sunday, January 17th, 2016, which is tomorrow evening UTC and around 10 in the morning local time. It will take place on the US West Coast at the Vandenberg Airforce Base, and the rocket will head for a polar orbit. This means it will fly in direction of the poles, from where it can cover a majority of Earth's surface. We will finally see what is going on in daylight, which might cause more excitement in the not so space enthusiastic media, and I can highly encourage you not to oversleep it. I'm not entirely sure if it's because of the payload's orbit or due to the fact that there is simply no landing site in Vandenberg, but the Falcon 9 booster will attempt landing on a barge in the ocean again, which is of course a little more challenging than last time, to say the least. But let's first talk about the payload, Jason 3. It is the 4th satellite of its kind following Jason 1 and 2, but also their predecessor Topex Poseidon, which was launched back in 1992. The Jason satellites are pretty similar to each other, and their main mission and focus are the oceans, more precisely the ocean elevation. The satellites, from which only Jason 2 is active, revolve in a highly inclined polar orbit at 66 degrees and an altitude of roughly 1300 kilometers. There different systems are used to determine the exact position of the satellite, and several instruments measure the distance to the ocean surface, from which the total elevation can be obtained. A radar altimeter solely will not be enough because water vapor, aka clouds in the atmosphere for example, have an impact on these measurements. Therefore they also shoot microwaves, which interact with moisture through the atmosphere to get an idea of how the actual measurement is impacted so they can correct it. One satellite needs roughly 10 days to deliver a complete map of the ice-free ocean elevation. This data helps to understand how water is moving, and this is important because water has a huge impact on our weather. Warm water streams coming from the equator can, for example, heat up entire coastlines in the northern hemisphere and change the climate completely. Speaking of it, the Earth's climate also has an impact on the ocean water, of course. The density or volume of the oceans changes with temperature, which for example can also lead to floodings. The overall ocean elevation is constantly changing, and probably the biggest changes are caused by the moon's gravity. As it orbits our planet, it raises the water level on the side the Earth is facing it, and decreases it on the opposite. This is of course what we call tides. Jason 3's mission duration is planned for 5 years, but it will very likely achieve much more than that. Jason 1 for example delivered data for almost 12 years, until it was shut down in 2008 when Jason 2 replaced it. Okay, now back to the Falcon 9 booster stage. This is a little speculative though, since I am not completely familiar with the trajectory. There are 2 possibilities, and it depends on how much fuel the stage will have left. It will either simply slow its descent and land far away from the coast, or reverse its trajectory and land somewhere closer to the launch site. The closer it lands, the far side can be retrieved, and this is very important because the rocket will be exposed to the elements during shipping. This means a storm or big waves could flip it, and that would be really sad. However, they first have to land it of course, which is, as mentioned before, more complicated compared to the landing last year. The Barge is moving all over the place, and hitting the right spot is probably the most challenging landing of a craft of all time, at least here on Earth. I personally think these can't be compared with those of Apollo, Curiosity or Philae, for example, because landing on another body is again a whole different story. However, I'm sure we will witness a SpaceX vertical landing somewhere in the solar system within the next decade or so. I'm really looking forward to that. An empty Falcon 9 booster would make a nice monument on the moon, for example. Anyways, that shall conclude K-News episode 28. I'm also looking forward to your comments and hope to see you in the next episode if you like. Auf Wiedersehen and thank you for watching.